Right, hello everyone, welcome to another stream. How we doing? There we go. Oh, I'm showing up a bit transparent. There we go. Welcome. My face. So basically, I need to just get these in there like that. Right, last stream, what did we do? We did the text rendering. So that was really cool. So now we've got better text rendering, a bunch of different sizes. We haven't really got many different sizes yet. Yeah, something we're going to, I guess I can just tidy this up in the future sometime. Yeah, so the text looks far better now, a lot more readable. So that's nice. But yeah, the UI just needs to be a little less big, basically, but it's good. So today we're going to do PBR materials. So just gonna make these guys look nicer. I'm not sure if I want to do use PBR in the end, or how realistic I want this to look. I don't think I want to do realism, but it just is something we can do where we can start making some of the surfaces look better. And we can just tune it from there basically. So, right, what I want to do is probably record a thing. Is this not all blinding white? It is, isn't it? Damn it. Get smaller then. Yeah, I linked to that on my Discord. So we're going to be going over probably this tutorial. There's also a shader toy as well. Doesn't that look lovely? So there's an interactive shader toy as well. We can play with some values and just see how it changes the surface, and see what contribution it has. But yeah, so I guess let's record an intro and then we'll right. Okay. Hello everyone, welcome to another devlog. So today what we're going to work on is making these spheres just look nicer, because right now the way we sort of shade these spheres is not very good. It's basically just a normal, it's a dot product with the normal of the light direction and the surface. So we want to try and just make things just look a little bit better, or much better really. So we're going to try and implement PBR materials, and I'm not sure if we want to go fully this route or fully into some form of realistic rendering, but it's a good start on just making things look better, and from there we can tweak it and change it later on. So there's a few resources that I'm going to link down into the description to be able to check those out in your spare time. So we're basically following this tutorial here, which is about 30 minutes long. It's by Victor Gordon. And then there's also this great talk about basically the physics behind shading, like light and color, and how we deal with how we cheat in software and how it is in the real world type of thing. So it's a good breakdown here, and I'd really recommend watching these videos. And there's also this shader toy as well, where you can have a play with like the different parameters and see it change live, which is quite nice. So again, I'll leave these in the description below so you can have your own little research. We're not going to be going into the details of how PBR works because it is a bit too complicated and it's something I don't really fully understand enough to repeat and educate other people on. So I'm just getting my hands dirty today with it. Cool. So I'll drop the links for you guys who are watching live because you might want to have a bit of a play yourself. Is this shader? We're going to be mostly looking at this tutorial here today because it does a really good breakdown of where am I even going? Because it does a real good breakdown on sort of like the algorithm. And then this one is great if you want to see about the physics behind light and shading in the real world versus how we cheat in the rendering world. So this is a real good one. Yeah, we're not going to watch this one today because it's like an hour and you can do that in your own time. But we'll be playing around with a shader toy probably and we might make something similar. Yeah. So where I want to start today is I want to reduce. Wait, do I want to re-mention anything? Yeah. And one thing I forgot to mention is this video by Victor Godin is that it's a tutorial, so it really breaks down sort of each step of the equation and sort of the different techniques you can use in your PBR shader. And there's also code examples as well, which is lovely. Right. I also want to another marker down. The thing we're going to start off with is we're going to reduce the scene down to a single sphere. And so we can just, wait, do we want to do a single sphere? We want to do a single sphere. Hey there, Gikos. Welcome. How's it going? Thank you for the raid. How did the stream go? Welcome, raiders. How you been? Welcome. Right, so where we're going to start is we're going to reduce this scene down to maybe a single sphere or maybe a couple of spheres. So we can just look at shading a single or a few spheres for now, not all of these spheres in the scene, right? But yeah, we're working on inputting PBR into our rendering pipeline today. If anyone has any questions about the project as a whole, feel free to ask away. I'll happily answer. Oh, sorry, the chat's on. Let me sort the chat out. Followers only mode, where's that? Sorry about that. Oh, shoot. Give me a minute. Off. There we go. So I had followers only on because someone decided to spam the chat with a ton of different bots. So that's hopefully not going to come back today. So yeah, you guys can chat who are not following. But yeah, welcome raiders. Hope you're doing good. Hey, Guest Cost. Thank you so much for the raid, sir. How did your stream go? So how are we going to reduce the number of spheres? Should we just up the... Yeah, but... Yeah, I'm just going to change the shader. So yeah, we'll keep the instances. But in the shader, I think we'll just say... prepare clusters at LOD. Here it is. We want to always enable it, isn't it? Wait. There we go. That's enough. Does flicker a bit though. Oh, that's alright. So we should be able to inspect them here. Then like so. It's good enough. Hey Alex, how's it going? Welcome, welcome. We're installing OpenSUSE and talking about open source licenses for the next libs we'll develop. Cool. Yeah. Would you use it? I guess it depends, right? If you're a software developer, typically you like MIT because it's kind of it's less of a pain in the butt. But if you're more of like a Linux hardcore, you know, GNU person, you like GPL. What license did you fall on in the end? Yeah, MIT is just more friendly to developers, isn't it? Yeah, better. Um, and also, what sort of are your libraries that you're working on? Okay, so we just reduced it down so each instance has a 2 by 2 by 2 set of spheres, and that's just a lot less complexity in the scene now that we can just, you know, zoom in and pan around and just inspect. Right. So, where do we start? So in this video tutorial, again, I'm not going to go over the the nitty gritty details because I'm not really good at teaching it or anything. But effectively, you have your pixel that you're trying to render. I guess that's the view direction and the light direction. Yeah, there's a whole bunch of little things. I guess I'll draw it as I write it, and it might be easier to understand that way. So I guess let's just start implementing some of this. So the stuff we need is fragment position, the normal of the surface, right? That's the position in world space then. Right. Okay, it's pretty simple. So let's just get these all typed out. Bum, 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 bum. So where are we going to do this? There's a function called sphere color, I think. Thanks, sphere color. So you have the normal that gets passed in, the color, LOD. Yeah, I was trying to do something a bit funky there. Right. So I guess we can make a new function now. And where we use calc sphere color. So this is is there a technical term I could use? I guess it's BRDF, isn't it? Right, that's the BRDF. So the thing as a whole, I could probably just say like calculate surface color. So the input right now, so there's the normal of the surface, you have the albedo color. And I guess we've got to pass in some other things as well. Hey, two, how's it going? I'm not doing bad, man. Not doing bad. Today was my first day dropping the kid off to being looked after since my wife has gone back to work. So we dropped him around the grandparents today. Is doing a little tester at nursery tomorrow and go around the other grandparents as well. Oh, for crying out loud, Matt, there's an Amazon package coming. Oh, what's going on here? Yeah, things are going good. It was a lot of adjustment today. I had to wake up early. My parents going to be here any moment. What package is that? I've got 2 packages coming. So late for an Amazon package. It's like, right, they're both coming. Right. I'm just keeping an ear out for that Amazon package. Could be here any moment. Hey, the green screen's still alright. That's good. Right, so surface color. Let's just fill in the bells and whistles. So rules of thumbs. Yep, don't negate dot products. Right, obviously. Divisions by 0. Okay, all good, all good. Right, so let's get these bells and whistles in there. Fragment position. So you only need fragment position because you need to calculate the view. When you calculate the sphere color, you do have the hit position. So I guess you're on the hit position, maybe. Maybe we should just fill in a strut if we've got to pass all this in. Camera position, light position. So there's many lights in the future, right? Yeah, we wouldn't have to care about that for now. Light color, albedo, emissive, roughness. Okay. So you definitely want there to be a strut somewhere. Let's call it a material. Yeah. So we can house at least some of the parameters. So let's just put U32 for albedo. And some emissive. Do we use emissive here? We'll see. Roughness. This is between 0 and 1. And then metal as well. Metalness. Again, between 0 and 1. Technically, you shouldn't have values between 0 and 1. Technically, it should just be 0 or 1 if you want it to be physically correct, but you're not limited to that. So what is next? So there's also like a concept of a light. I guess we should probably do that as well. Just put in a strut and just make it so it's just all bundled together and a bit nicer. Lights, you probably want to have a color and intensity, really. So it's kind of the intensity as well, isn't it, really? Then you want the position. So world space position. Yeah, Chandu. Yeah, it's gonna hopefully look far better. Good. It's gonna be a good start. As you'll see when we start typing out some of the stuff, there's areas where you can tweak it and replace it with different algorithms. And so we're just gonna use the common one. And so maybe we can play about with this in the future, or perhaps we probably keep it like this and apply some post effects on top or something. We'll see. No, I didn't stream yesterday. This is the first stream. No. I stream Sundays, Tuesdays, and Thursdays. You also relay the YouTube videos to them. Yeah. I put links out in the. I'll relink them again. This one is a good tutorial and it's the tutorial that we're following. This one is a great talk on the physics behind light, color, and everything. I've watched this one like 4 times, and then also how we cheat in the rendering world, and what we do and what we don't do, and how we model it in code. Yeah, really good talk. And then there's also this shader toy where you can play around with it. I've looked at the code here and it's a bit hard to see the breakdown of the rendering equation in here because I'm not too familiar with it. So I'm going to follow the tutorial. But you can have a bit of a live play around here and see how things contribute and things like that, and learn from it this way. So yeah, I'll link that again. Yeah, this is what I've been looking at, plus some other things, but these are the main ones. So a bit of a light. Now the color is probably... See, what's the technical terminology? Because there's like radiance. There's like radiance, right? But that's not what comes from the light. There was a PDF that I got on my phone, and I was looking into it. But radiance is the radiant flux emitted, reflected, transmitted, or received at given... Right. I wonder what the technical term is. See, A is what in there? Luminance. Is that what it is? Luminance. Maybe. Yeah. That rings bells. So maybe you have luminance. And is luminance like... I guess there's many different ways you can represent it, right? Basically. Yeah, luminance. And is that like a color? Luminosity or brightness changes. Okay. That could be a separate scalar, I guess. And you can set the color as some... You could pack it down, I guess, right? And you have a luminance value. I don't know if that's how people typically do it. Right, there's the doorbell. Be right back. Right, there we go. So just picked up the Amazon package. Oh, so it's good. Comes so late sometimes. It's just weird. So here, they say luminance as a full color then. Imagine when you're picking a light color in like an editor or something, you want to pick a color and then probably how bright it is separately. So I think it's good the way we've broken it down. Not so much sure in a shader, but yeah, luminance is probably what we want. So you have luminous, flux, lumens, luminous, intensity. Man, what's this drawing? LinkedIn. Ugh. Luminance. Yeah, I don't know what. Ooh. Maybe it's just intensity. Maybe just use a different one. Yeah, maybe intensity is fine. Yeah, screw it. Let's just say intensity. We can make it more technical correct later when we do lighting properly. Alright, that'll do it. We'll store as sRGB. Do you want as sRGB? We'll convert it into linear and then multiply it by intensity maybe. Yeah, Chandy, there's plenty of people who do graphics programming in there, including myself. You can always ask questions, that's all welcome. Right, so position, color, intensity, and direction. This is a directional light. So we'll just put direction in there. Okay, so I think that sounds like a bit of fun. Putting those into some structures at least. So which ones are we missing from here? There's obviously the camera. Camera position. So that should really be a global. But we're not here to make. Should we? I guess we can have a camera strut as well. We should probably start having one of these because I have like field of view and it's just hanging out separately. So I guess for now we'll just put a position in there in world space, and there is like a field of view thing that should go in here. But let's just do that. Maybe. Let's just put the FOV in there like that. Cool. Right, so I think that's all the bells and whistles as inputs. There is probably just normal that needs to go in. So when it comes to passing stuff in, we want the material of the surface. Then we want the light. Now, I guess this is like, you probably should do a for loop over all your lights, but we haven't really got multiple lights. So for now, let's just not care about that, I guess. And just start with the basics. So material, light, camera. We're probably only gonna have one camera. Yeah, so we need the hit position, isn't it? Position world space. So it's a bit meaningless. Surface position, surface normal. So I think that's probably good enough for the inputs for now. Maybe we'll drop the camera one. In my globals, have we got the... hang on a minute. Yeah, float 32 times 4 is a vector 4. It looks like that. So it has some basic swizzling support, some ordered swizzling, and yeah. It's just a vector 4. Shoot, close the wrong one. Right, do we have the camera? We have FOV. Let's just put in camera position. Camera, pause. World space. So I need to upload that. Let's poke that in. Globals, camera, position, world space. Now, how do we get that? Well, I think we construct a matrix at the top. View from world. So I think that's just poked into the I think you can just use the rotation translation. Yeah, maybe we need translation X, Y, Z. Wonder if I can just use bx times whatever's in that column, right? You know what? For now, our position in world. All right. Right. Camera position in world. There we go. So that's uploaded to the GPU now, available in the shaders. So I think we've got all the parameters here as input. Right, and then we need to produce these main vectors here. So we have n normalized normal, right? Okay, so we just call that surface normal. That's fine. This is v for the view vector. So surface to view, I guess we'll call it, or view from surface. Bit long though. This is why they just use v. Oh, anyway. Maybe we'll just do the shorthand. V norm f32 times 3. Then we'll do a subtract towards the camera position. So that's GFX global camera position in world space. So going towards that from the surface position in world space. Okay, so then we are, so we've got N already, we've got V. L is the light position, the directional lights. Oh, right, so that's kind of implied. So I could call this view direction, light direction. So we can norm light dot pause word space. Wait a minute. No. Yeah, that doesn't make any sense. If it's a directional light, there should just be one field called direction. Yeah, for point lights and spotlights, which we don't have. And then H is the half vector, I guess that is. V, L. So this one is... So you have your point you're trying to render on the surface. Your camera's over here. Your camera's here, your light is coming in from a direction over here. So the reason why you have this half vector, so if your view vector going that way, then you have your light direction going that way. And what you're doing is computing the halfway vector in between those. So it's by adding the two together and then normalizing it. So you're adding that and that, which get you that basically. And then renormalizing it again. So that's the halfway vector. And the reason why you have this thing is so when you calculate the specular light, you use this vector to tell how close to the perfect viewing angle you are to see the specular light. And you do that for every pixel on the surface. So that's just called the half vector. But yeah, if you watch the videos, they explain it much better. But the idea is that, yeah, it's for the specular light basically. Call it half direction maybe. So we're looking at doing something like this. So we're adding view direction, light direction, and getting the half direction. Cool. So that's basically the first set of things to to do here. So what we can do is maybe do that. So I guess we could plug this all in and get it working first, and then everything we just add, we can just see it come in, maybe, right? So let's go start with that in mind. So effectively, you still probably have something like this, where you do a dot product with the light direction and the surface normal. That's how much, that's like cosine theta, right? But wait, why didn't I negate it? Right, I needed negating because the light direction used to be flipped. It used to come from that way, but now in the new code, the light direction comes from this way. So that's the reason why there was the negate there. We don't need that anymore. So yeah, it's like a positive cosine theta basically, an absolute value. Well, no, absolute is max with 0, so we clamp out the negative value. We need the color of the light. So we want the light color, which would be sRGB linear. We're converting light.color, and then we're multiplying that by light.intensity. That's the light color. Now, yeah, so you got the surface color, where's that? Material albedo. Right, so I guess we'll do this for now. So, sRGB to linear material albedo. So this is a very basic version, but we can at least start plugging it in. Material.albedo. And then you multiply that with n.l. The problem is that's not a float. Oh, okay, that was good. This isn't a. This has got alpha on it. Probably not sensible, but oh well. Dot .xyz or RGB. Oh, there's another one called material, is there? Whoops. So I've already got one called material apparently in the code base. Classic. Not used anywhere, so we can comment that out. Right, it's just called direction. Light.direction. See, I guess you probably want it in a local variable when you add different light types. So maybe we'll do that. What? Oh shoot, am I trying to do a multiply? Mismatch does not implicitly cast to that. Wait, what's going on with that sRGB to linear? Why is it? Oh shit, I need to unpack it first, isn't it? Whoops. Unpack. Unpack. Yes, this is where we should be doing the multiply. Whoops, get rid of the multiply. Cool, so now let's try and plug this in. Instead of sphere color, we're going to use calc surface color. So we need all these bells and whistles. So color, material. So let's just fill it all in. So if we upload this via the globals, we could just put sliders on everything. And And that would be a lot better, right? So I think that's a good place to start, is in the globals. We're just gonna, just take this, see the light, color, and intensity. Things about the color though. I'd have to put a bunch of different RGB sliders because I don't really have a color picker widget. That is okay. I can just make one temporarily, just for this demo at least. We can start off with something like that. So we want basically a light, a material that everything uses for now, and a light. That's pretty cool. So we'll pull that in. So here we're just simply going to read that out. So this is just going to be equal to GFX global material. And then light is going to be equal to, obviously, light. So we just pass those in here. Surface position, that is, so hit normal. I've got hit position as well, I think. Hit pause. Oh, right. Right, that all compiles. We've still got to fill the parameters in CPU side. So we shall just look at that now. So I think we'll just create them here. Material. So in future we might add texture support. So obviously having them as hard-coded scalar values is not going to work in the long run, but for now, or we're just getting the base of it in, it just works like a charm. So here we can just say color red. Well, let's do something different. Let's do, well, blue's really ugly. You know what a good color is? Teal. Get that one in. So 008080. So we've got to reverse that the other way around. So 80 blue, 80 green, 00 red. Love me a bit of teal. Nice. Emissive, we'll just zero that for now. Roughness, let's just do 00 on those. Then our light. So where's our light direction is hard coded. Let's nick that one. So it's coming in from, like if we're looking down at the scene, it's coming in from the back, just a little bit above. Yeah. Direction, color, let's just do white for now. And then some intensity of, I really don't know. Usually they're quite high, but let's just say 1 for now, and we can monkey around with the value in a bit. So we just got to plug those boys and girls in. So they just go down here. Globals, material, equal material. Globals, light. So we should be able to add some custom UI to play around with all that soon. Right, so something that I was thinking about. Why don't we RGB this part? Because that's an extra multiplier we don't need. there. It would probably figure that out and compile it out, but still. Right. The alpha, I guess we'll manually pack that out. Yeah. Cool. Fast, what is it? Fast 3? Yeah. Sweet. Oh, this one's a vector 4, does it? Okay, I guess we'll keep the alpha. Yeah, but you don't n.l the run aloud. Right, so there's the actual overall color, and you return color, wait, color.r, color.g, color.b, material, albedo. I guess I've got the alpha in there. So the alpha's at the end. So shift right 24. Multiplied by 255. Wait. Yeah, 0 to 1. Sweet, so I think that's everything. So let's give that a go. Right, so we've got the teal looking color and everything's upside down, so the light direction at least is coming in the wrong way. I forgot about that actually. Right. Yeah, I remember now, we need to flip it. So negate. Yeah, so the direction where it's pointing to, but we want to make sure it points towards the light instead. There we go. Cool. What's going on? Right, that's in view space. It's responding in view space. If I tilt the camera, you can see it tilts with the camera. Funky. What's going on here? What's the issue? Could it be... We're not using any of these yet. We're using light direction. We're using light direction, surface normal. The light direction is not changing. So we're not really using these views. What's in view space then? It's... Oh, is the surf... Wait a minute. We're only using light direction. The surface normal is in view space. That's the problem. So... Yeah, normal world space. It's right here. Cool. There we go. So we got our teal colored. Okay, that's good. Sweet. So what are we planning on doing? Yeah, let's record what we've done because it's a nice little setup we've got. Okay, so the first part of the tutorial, one time. Right, so the first part of the tutorial provides a bunch of like input parameters you need and sort of constructs these main vectors that you'll be using throughout the equation, basically. So what I've gone and done is made a couple of data structures. Material, so it's got albedo, emissive, roughness, and metalness. And then a light structure, which is basically a directional light with a direction, color, and intensity. And these are passed in via the global data structure. So what we can do for now, whilst we're just testing things out, is from the CPU side, we can fill these guys in. And actually, we can put a piece of UI up, and we can make some tweakable values with some UI. So we can play around with these things live. So this is going to be a big help when we get the algorithm actually going. And then I've got this calc surface color, which replaces calc sphere color that we had before. That's the temporary one. And we've just got we calculate those vectors there. We pass in the material, the light, the surface position, world space, and surface normal. And we just have basically plugged in the old code into here. So we calculate the n.l, which is also cosine theta, which you see in the videos that are linked. We calculate the light color by unpacking it, turning it from sRGB into linear space, and then multiplying it by the intensity. Then we compute the color by unpacking the albedo, changing it to from sRGB to linear, and then multiplying that by the n.l. And that we just basically passed that out for now. So we're basically getting the same thing, but I've just changed the base color or the albedo from red to this lovely teal color. So what we're going to do next is try and add some more of the PBR stuff to that code and just sort of see it gradually come in. At least we hope. So let's move on. Why am I seeing anything? Right. So basically there's a few versions. Yeah, there's the rendering equation. I don't know where this is. It says 1117, let's remember that. So the road bridge, what's that part of? Where's my headphones at? Boys out. No. They're breaking. I use these every day. Right, what's the road bridge thing part of? For now. Version model. Right, it's probably part of the specular then. No? DGF. Lawrence. Where's the road bridge? Normal distribution function, right. So there's like 3 to pick from. There's this sort of Beckman. Oh, there's a few to pick from. He goes with... Yeah, so he goes with this one here. 1117. Right, so let's port this code over. So you have this thing called alpha come in, that's surface normal and the half vector. So normal distribution function. Right, let's get that all typed in. We'll return an F32. GGX row bridge. So this is our normal distribution function, and we're going to pass in some alpha value, which is not it's not transparency, it's something else, which I still need to learn. I think it's been mentioned, but I've forgotten. And then this is half the direction. So numerator pow alpha 2 n.h. So I guess some of these could be reused. Max dot surface normal half vector denominator. So we need a bit of pi. Did I yeah, I don't really have a bit of pi. Let's get a bit of pi in here. We should probably have that in our GPU shared. I should probably have it in my maths library maybe. Because yeah. Anyway, we'll get a bit of pi. Denominator denominator, there we go, right. Pi multiplied by pow n.h 2 multiplied by take 1. Hey Jax, how's it going? Too old with my beard. Yeah. I guess so. Makes me look older, like a wider jaw. Shave it off, I'll often go skinny. It's the power of the beard. Never doubt the power of the beard. I need to probably get my haircut soon anyway. Getting a bit long. Right, that seems legit. Then we max it with, right, to prevent the divide by 0. So we probably want like an epsilon of some kind. See, there's so many zeros. Yeah, let's just hard code it. Sometimes epsilons you want a different one for each thing you try and use it on, sometimes. Right, a lovely division in there. Right, so the inputs here are surface normal and half direction. So if this becomes too computationally heavy, I guess you can sometimes bake some of this out into the texture or something. Because it's quite, there's only a finite number of inputs and you probably interpolate or just pick the closest one. There's this alpha value as well, whatever that is. But yeah, great. So there's our first function. Let's look at the next one. There's a normal distribution. Now the next thing is the geometry shadowing function, and then the see what is this? Isn't just the geometry. This is the geometry because there's shadowing and then there's so shadowing is when you there's shadowing and then there's something. I forgot the other term now. Right, where's the G? Specular term. Right, G, okay, is the shadowing function. Fair enough. The geometry shadowing function. Right, let's type this one up. Game, what is the game? I've got it the design written in a document, but we're doing some rendering R&D at the moment. We've done a few different we've actually got many more spheres. This is me just bringing it down to a few spheres. It's like a sphere-based renderer with ray tracing, basically. But we're going to be going back to a BVH very soon. I'm holding up on too much of the details because that's coming after we've done this PBR work. But yeah, we've been experimenting with how's best to render a bunch of spheres, and I'm just going to settle on using a BVH. And I've got some more surprises coming when we start that work. So we're going to go back, do an improved version of the previous BVH code we did before. So we start that from scratch again. But we know what we're building, so it'll be a lot quicker. And then move on from there. Basically, we'll have PBR and a BVH. So we might as well do better lighting, right? Because if you have a BVH, you can cast rays from anywhere, and it's accelerated, but it's still obviously painfully slow if you shoot tons of rays. So you really want to be careful. But we can have a play around with different lighting, I guess. And yeah, so just doing some rendering R&D for now. And I guess after we've played around with that enough, we'll start probably building some tooling to make some models, because we're making models out of spheres, so we need some good tooling. Custom tooling, and we've got custom UI. We've built stuff like this texture viewer, so we can go ahead and build more UI. Nice and easy, I'm sure. AI brain visualizer. AI. Everything in tech right now, AI. How come you don't have channel points? Make you do extra curricular activities. I used to have some where I would lift weights, and then people would spam me lifting weights, which was fine. But the issue is I only have so much time in the evening now, whereas I used to stream like all day basically for like 6 to 8 hours. So I used to just sort of, the people would like save up all of their points and then spam lifting weights. So I would like just do a whole bunch of stuff, which was cool. Yeah, I know you can have cooldowns, but that's not the point. Hey Dory, how's it going? But yeah, maybe in the future, if I ever stream for long periods in the day, for whatever reason that is, I'll probably bring back something similar. But for now, no point. So this is the Schlick. What a great name, the Schlick. Just sounds good. It feels good to say. The Schlick Beckman It's a combination. I guess it's this guy's custom one. Maybe other people do this. This is the geometry shadowing function. And then there's mixed with the Smith model beneath it. Right, okay. So, geometry. So, I remember watching in that other video, there was shadowing. Kind of know what. Yeah, there was shadowing, and there's another one. I might be able to find it in here. Here it is. Shadowing and masking. That's shadowing. And then masking is when your specular. Yes, this is the light being masked and being shadowed, and masking is I guess the specular bouncing off and going towards the view. That's masking. Okay. So I guess we don't handle this case, or we just handle that case. I don't know. Goes over my head. Geometry shadowing function. Glad you're doing PBR now. I'm at advanced lighting section now and learn OpenGL. Now I need to get spoiled for what's PBR. Awesome. That's really cool. Yeah, I need to even do proper lighting in mine. That'll come next. But yeah, PBR is quite nice. Like, you see people mix it with like, this is another reason why I'm doing it. You see people mix it with non-realistic art styles. So it adds a level of, I feel like it probably just adds a level of quality. And you don't necessarily have to go down the realism route. So, you know, if not, you're just stuck with basically toon shading, but people mix toon shading and PBR. I've seen that. Or you're stuck with Phong or Blinn. And I guess you could do something custom, but I tried Googling the crap out of everything. And it basically just falls down to PBR based things. And obviously PBR isn't a fixed thing. There's like tons of different configurations and specialized versions for like tons of different effects. So there's like clean coat and yeah, tons of different parameters you can add on top. So it is a generalized term, which means a whole bunch of different things. But I think people typically do what we're writing up here. Yeah, because this guy did all the research and he looked into what people are doing currently from what I know. And there's an X parameter. Right, we'll just call it X. So X is either the n dot, is either the L or the V. The light direction or the view direction. So it's just some kind of direction. Ah! So direction towards the view, directions towards the light. So I guess this does the shadowing and maybe masking at the same time. Yeah, it's interesting. Let's just call it X. Denominator, no, numerator. So this is reusable, right? I guess the compiler will figure that out. Not gonna lie. But I guess it's good to optimize this sometimes. There's a variable called k, alpha divided by 2, denominator. Let's copy paste it to begin with though and change it up. So max n.x. So I guess we're doing n.x local. Oh, max. Wait, did I max 1? That was a mistype. 2 seconds. Obviously it's 0. Yeah, cool. Right, that was the mistype. Right. Cool. So n.x. What are you doing with that? Some max. We've already done the max. So then it's a multiply. So you're wait. That multiplied by 1 take k. So I guess the I forget where the mess one comes in, but maybe it's somewhere here. Oh no, it's way earlier actually. Yeah, he adds it in at the end of the video. Denominator, and then he does this sort of max thing on it to stop it from the division. Right. So that looks legit. So multiply it by 1 take k plus k. Cool. So we then want to make the good old Smith. Just have a function called Smith in the code base. I'm sure that won't have problems. It's such a common surname here in the UK. Right. V direction. Light direction. And then we're going to return schlick. And that's good. Schlick. Alpha. Surface normal. View direction. Multiplied by this again, but with the light direction. Right, and I've put the word model in here, so just to make it extra obvious, it's an AI model. No. Yeah, so we should probably call it the Smith. But yes, the geometry. I don't know. Let's just call it that. Like Stellar Blade real, if you know what I mean. Yeah, I actually played a bit of Stellar Blade. I've only played up to the first boss, I think. Maybe a bit further on, after you get to the first base. But the gameplay feels like a lot of fun. I'm really enjoying that game, so I had a chance to sit down and play with some more. Hey Jack, how's it going? I think the benefit of this is that it just makes the lighting look so much better regardless if you actually style your objects, and lighting can be make or break visual effect. Yeah, that's true. Like I always call back to the Minecraft Minecraft RTX. When I first saw that, I was like, wow, lighting just really makes even just bricks look better. Huge bricks look better. Where's the field one? Obviously, there's a bit further away. Where's it where they go outside? Here. Run out loud. I saw a better one. So when there's a big landscape. But yeah, people were putting custom texture packs on top of it, making it look even better. But I saw one with like a 16 squared texture, or the standard one. Yeah, this is with like better texture packs though. Yeah, good line just makes stuff look better. Do you use threads or multi-core for rendering? You do this after 8-hour job. Second question, yes. I work on this after work. Yeah, I don't mind it. I really like programming, so I don't really find it a problem. And I've been doing it for so long, right? About 15 years now. So I've got just the habit of working long. Um, and not getting distracted as well. And also streaming helps with not getting distracted. Um, multi-threading. We don't have any multi-threading on the CPU yet because it's not really been a problem. We're not really running a game at the moment. We're just doing pure rendering code. Hey, Isaac. You can take a look at OpenPBR2. It's more of the surface description you can use to define your own materials. Ah, interesting. Have you got a link to that? I'd like to take a look. Yeah, I don't have a strong British accent, that is for sure. Also, there isn't really a British accent. If you understand Britain, the accents vary so much. Like, if you live down south versus London versus different. Obviously, this is. I guess anyone who lives in any country could probably say the same thing once you're in it and live in it. But, and as you go up north, they get better. If you in the Midlands, they kind of. They actually do very a lot in the Midlands as well, but and then up Scotland as well. Very different accents. Very different. Intel HD graphics 620 Chrome right now. Yeah, I got my 620 laptop right here that I'm watching the chat on. I want to try that one out. I want to try this game out on that and see if there's something we can do. A bit fun. How do I have back pain? Yeah, I do. I have experienced a lot of RSI over the years. But I've started to eat better, eat more healthy, and I exercise every day. And I try and fit a real good workout in every 2 to 3 days. Trying to put on more weight, it's difficult. I don't understand why it's difficult. RSI, repetitive strain injury. What exercises do I do? A lot of different ones. I try and work out everything. So I do my hands. I've got like a hand grip strengthener that I use. I use about 10 kg weight and use my whole body. Do my shoulders, do my chest. I do obviously squats, all sorts. I do curls for my wrists. Standard, forearm, stuff. Will that fix your back? No. Your back has got have certain set of exercises. You can just YouTube like exercises for this, and you'll get someone who's like real good at it, and you just do that. Yeah. Honestly, if you want to fix your back, go on YouTube, search for people like exercises, give them a go on a low weight, maybe just a body weight, and just get a feel for it, and then add a bit of weight to it if need, if you when you've mastered the technique. It's all about the technique. You want to get good technique when you exercise, because if not, you can make yourself worse. Okay, interesting. I'll take a read of this out of off stream. Thank you so much, Isaac. Yeah, man. I've experienced a lot of joint pain as well. I know it's something you definitely need to look after. Right, I'm gonna see. Yeah, just keep it up. I won't give up on it. Right, the F function. So this is the Fresnel Schlick. Man, what a name. So if you guys don't know what Fresnel is, this is where like as you get to the edge I'm not sure if I can do it justice, but I'll try anyway. Teenager. The Fresnel. There's a good. It's pretty cool. Yeah, here it is. So basically, like, as you get to the edges, you're more likely to get. So red is like 1, and then green is like closer to 0. So you get like a 0 value on stuff that's pointing towards the camera, and the stuff that's pointing perpendicular to the camera, basically, you will get like a red. So that's what the Fresnel is. So if you look at sort of like. Yeah, it's pronounced Fresnel. Yeah, it's French. It's a bit like Godot. You know, so isn't it Godot? No, it's Godot apparently, because the French. Godot. There we go. Great engine. Yeah. Right, so this is the Fresnel. Fresnel does sound nicer though, not gonna lie. Fresnel. So you get a bit of F0 in there, and you get a bit of V, a bit of U norm, a V direction, and a bit of half vector. You know, just a half direction. So for now, schlick. You can't not have the schlick in there. So this one is F0, right? It's a vector. Bit of F0, bit of, right, one take. What else is going in there? Multiplied by some power of 1. Right, so that's a scalar. Wait a minute, this is like half fading out. There we go. Multiplied by a scalar of pow float 32. One take. Now we probably should put this into a separate line. V, so let's take that. V dot H. V direction, half direction. V dot H. Five. Magic 5. So let's read that over one more time. V dot H. Yep, that's correct. We add F0. What a game. What a good game. Subtract vector 3 of that with F0, so basically just invert it the other way. Why is there a comma there? Oh yeah, multiply. Multiply the result of that by pow 1 take V dot H. There we go. Then to the power of 5. Cool. So for now, schlick is in. So I guess we just plug it all in now. Right. So I need the Lambert part. There's a bit of pi in there as well. There's the Cook torrents. And then Wait, where's all the... Ah, here it is. Coctorrents. Right. So this is the specular component, right? Where's the specular component? Yeah, KD times Lambert plus Cook-Torrance. So this is the... Yeah. So this Cook-Torrance is the specular component. KS. Where's the KS? Where is the KS? Because if we go back to here, specular is the Cook-Torrance or Torrance-Sparrow thing. And then BDRF is K. Where's the KS in this equation? KD is there. And where's alpha? Something's missing, right? Is alpha actually supposed to be KS? No one tested the code. Yeah, KD is equal to 1 take KS, right? But right, I guess it just cancels out the KD then. And then the specular thing is... Yeah, so I wonder where's the alpha coming in? I guess people pick a fixed value for that, I don't know. But anyway, let's write this up then. So this would be the BRDF part. So let's get the BRDF. So BRDF needs to be KS. So it's the Fresnel. Wait, is that what the F was again? It was, wasn't it? Fresnel. Fresnel. Schlick. There's an F term. So I guess F0 and that is configurable. Wait, where did the... I haven't seen F0 in here. So that's where the metalness goes in. Yeah, it's missing whatever F0 is. And alpha. We need to get those values somewhere. Oh, there is text about F0. Thank you. Where's the text about F0? But yeah, I guess we have to look back at the equation. There's nothing about F0 here, so I can't see any text about it in this tutorial at least. We can find the values from the other examples basically and bring those in. So it's not an issue. Let's just type all this out then. So bit of select, we need an F0. View direction, a half vector. Is the index of the refraction. Ooh. Yeah, I remember seeing it. There's like a... Yeah, I forget it exactly. But isn't it like for metals and sort of dielectrics, it wants to be different? Oh, 1243, thank you so much. Oh. Oh, it comes off. Okay. It is. Have an accurate F0 or be lazy. Basing the albedo of the mesh. Something you like. Right, okay. Need to have a bit of a play. It's alright. Yeah, it's cool. Fancy having a bit of a play with the whole thing in general at some point anyway. Making something specific for this project at least. Right, here we go. Right, let's type in all these bells and whistles. So, cool. KD. Sub. I could just say S sub actually, I've got that. Don't know why I didn't do that here. Where I can pass in a scalar first, and then the vector next. Yeah. Good. Past Henry, killing it. Lambert. This guy only gets a variable name. The other people get like, whole functions. So albedo. So I guess we'll pass in. Do I want to pass it all in? I guess so. Pass in a bit of the material. Bit of Lambert. The albedo. I think that's needed anymore divided by pi. Bit of pi. Then cook torrents. So maybe we should have that as a function. You need a lot of parameters though. You obviously need the light as well. Screw it. Cook. Torrents. Light direction, view direction. And then we need the alpha value as well, which is something else that's missing. But we'll find that out. The alpha value. Right. So there's a similar sort of setup. There's a lot of this. Numerator, denominator. Where it is then, so D was the normal distribution function. So that is, see what was F again? What does that mean? Is that just for now? Yeah, for null function, right? Okay, obviously. All right, let's get back in there. So normal distribution function. Alpha surface normal. Oh, I ain't got that one. There's a lot of parameters. Not usually a fan of that. Passing tons of parameters in. Half vector. So normal distribution function, the geometry shadowing, Smith geometry. If alpha was the roughness, right, that's probably it then, because yeah, I haven't seen the roughness being plugged in yet. Awesome. But it could be that the... Yeah, it might be the roughness then. Yes, it's the color of the specular reflection. Metals absorb certain wavelengths, non-metals do not. So the specular highlights are the color of the light. Yeah. Yeah, I remember seeing that actually. When I played around with it here, if you select something that's metal, the Fresnel gets colored, right? Where the geometry is not colored. So the diffuse, the diffuse is not colored. That's what I mean. When it's metal. But when it's dielectric, the diffuse is colored. So that's the stuff that's bouncing inside the... yeah, so you don't get any diffuse color on a metal. But on a more plasticky surface or something dielectric, you get this diffused term. Or color from in the diffused term. Whereas you get it from the specular in metals. Yeah, it's interesting. Always confused why. I was always confused how you get color if metals don't have in the diffuse, but then I played around with this and found out it's in the Fresnel. That's cool. YouTube tip: you can get better preview. We can drag the slider. Nice one. Thank you, Sammy. It's a bit faded. Oh, bring it up. Right, okay. Thank you. Yeah, I didn't realize you could drag it up. So the geometry, Smith geometry, surface normal view, direction, light direction. View direction, light direction. Wait, where's the surface gone? Cool. Next one is the Fresnel, probably. Fresnel. Schlick. So that is a bit of a F0. View direction. Right, so this is called again twice. Okay, that's obviously can be... Yeah. You probably just passed in the Fresnel. Well, the compiler can optimize that. But yeah, this is stuff we can definitely optimize later. Right, let's just get it working. So that looks alright. Alpha normal half. Alpha normal half. Alpha normal view half. View light, sorry. F0 view half. Sure. Right, now we need the denominator. So denominator, probably max as well. I already got it here. So the denominator is 4 multiplied by v dot n. V dot n multiplied by L dot n. L dot n, cool. Then the max, yep. Then the sweet. So that's the cooked torrents. So we do the BRDF, you do the Schlick, do the Lambert thingy, do a little bit of cooked torrents. I guess we won't do it at space. Alpha, so I'll work out what alpha is. Again, it's probably just the roughness. So, sorry, what I'm doing. So surface normal. Light direction, view direction, half direction. So torrents. Right, now we can do the BRDF. BRDF. KD. Lambert. Torrents. That's the BRDF. I'll do for now. Then outgoing light. So we should return the BRDF there. Like that. Sweet. So now we've got the BRDF. We just need to produce this outgoing light, as they call it. That's just color for us. So color equals. Wait, did we not use the KD? Oh, we did. So emissivity. Right, interesting. Emissiveness, right, of course. So the emissiveness. So we only needed the albedo in there, but some more bits. Emissive. So emissive, let's unpack it. sRGB beta linear. Then you can't get anything else that's super bright if it's just an extra one on top. Maybe you do emissive color then intensity, but yeah, maybe there should be like an emissive intensity somewhere. I don't know. What is emissive right now? That was 0, wasn't it? Yeah, so emissive unpack RGB. So emissive plus BRDF multiplied by the light color multiplied by the n.l. So light color Right, this needs to be a bunch of these thingies because we've not got operators. So add BRDF is like 3 as well. Shoot, this has to be a damn. One of these as well. Right, multiply BRDF, light color. Wait, where's our BRDF gone? Did I not write it out? Whoops. Where's that come in? So light color, multiplied by an n.l. So n.l is a scalar, so it's an s. So n.l is scalar and follow. Cool, so I think that is basically it. We just need to put in the, get the BRDF out. Calculate BRDF. Material goes in, surface, normal, light direction, view direction, and the half direction. So now we've got to just fill in fix all the compile errors, and there's a bunch of different brackets that are not closed. Right, what is this? Now Schlick. Oh, is that cook torrents to vector 3? Whoops. Did not see that coming. Numerator. Oh, did I miss? Oh, thank you, Infros. Oh, plus the cook torrents. Good catch. So mol. Wait. Yeah. Add. What we got? We got Fresnel yet? No. I've not individually. I've not made them conditional yet. We should probably make them. We should probably basically make our own version of this shader here, where we have a bit of a play. Maybe just see individual parts, toggle parameters, and see change stuff like the base color and roughness and that. Obviously not do that, but just see these parts separately. Do wish you could overload operate and see right now. I don't know, because people do like really stupid stuff with it. See, the benefit of this is that it's more understandable what instructions are being called, right? It's clear. You can see like, oh, this is actually doing like 3 multipliers or whatever, right? And you're not just left to trying to chase down the type definition, and especially if you're using like all these newer languages where they have like auto or type inference. It's basically really difficult to find what the type is, and then you just left to try and understand the code a lot more to figure out what's actually going on. So there are advantages when you read back over the code when you see exactly what type it is in the names basically. But yeah, operators are kind of nice to make stuff condense. So it's pros and cons. I could probably do with making some of these names a bit shorter, but that'll come someday. What was I going to? Yeah, so we fixed that up. Oh yeah, we're just in the compile errors. Also, this row bridge thing is a float. So is the geometry. But the for now is right. Yeah. But the for now is right. Okay. So this is a color. So these can actually just be to do the Fresnel first. We'll do it backwards. No F0, no. So yeah, F0 we want to play about with in it, so. Wait, F0 is a vector 3? Let's go back to the Fresnel thing. Right, okay. Yeah, don't you just love C out? Yeah. The tooling these days is very good. You can find a type easy in general with the help of an LSP. Yeah, but the problem is you need the tooling. Right, when someone sends you a code snippet or when you scroll through GitHub, you don't have that tooling. And people say, well, you just download the code or whatever, but and then get it running on your machine. But it requires the whole setup to be there and all of this. So I feel like the tooling argument is a bit of a non-starter, really, because there's so many cases when people send me code and I just it's got like an auto in there, and my chat has decided to freeze on my. Right, it's come back. It's good. Right, so one of the. I went times 3 on that one. Right, so this is a div or just. Denominator is a float. Cool. Right, so I don't have the F0 here, so we'll get the F0 in there as well. Right. Calculate BRDF F0. Right, so I don't know what F0 is going to be, to be honest. Wait, what did Render Goblin say it is? It depends on the index of refraction. Okay. Look at the link. Right. With some languages, GitHub uses tree sets to help you with that. If you click on the variable, for example, it shows where it's defined. You go, I'm trying to say, yeah, okay, I've seen that actually now. I don't remember. Yeah, I guess you can see where it's defined at least. But yeah, it's still less readable when you just scan every code. Right, so they do like a 0.04. But yeah, we want to. Yeah, there's definitely some conditional sort of things here we want to put in there. With the surface color metalness. Right, so let's just for now write that up, and we can look into it later. Right, so lerp. Have we got an slurp? No, that'd be slurp. I don't have one of those. I didn't mean spherical lerp. I meant like a scalar as the first argument. So then surface color. There's material, albedo. Should probably unpack that. Yeah, maybe we should just have these all unpacked. This will do for now. Bit of albedo in there. With the metalness. Right. Cool. F0. Where's the music at? Right, so that'll do for now. Capital KS. Alpha. So you think alpha's the roughness? I don't see any roughness. So I imagine it is that. Yeah, man, he's in one monitor. And he recently just got a new monitor as well. So when they use a distribution term, yeah, I wonder why people do PAL 2. When you just square it. I don't know why I'm using the PAL function. Like an absolute rookie. Yeah, that's not good, is it? But yeah, so they are squaring it. So why don't just call it roughness? I guess that's just part of the yeah, so we should just maybe call this roughness instead. There's probably a reason. Yeah, I got the laptop on the left hand side for the chat. Yeah, dedicated chat window. Yeah, the streaming comes from the main PC and all that jazz. Maybe we should rename this just to roughness. Unless anyone tells me otherwise, it's going to be called roughness. So in this case, we have the material roughness, and it all goes through there. Right, lerp f32 times 3 with an s on the end because we've got scalar at the back. Right, why is this one failing? U64. Where's the U64 at? Oh, a bit of pi. Let's F that at the end. Alright, we're all compiling. Exciting. Right, so let's kick this thing off and see what happens. Pitch black, as we probably would have expected. Oh, what have we done? You want to hop in a rabbit hole for why roughness is squared? Sure, go ahead. I was bedridden for a month because of an injury, which forced me to use one laptop, one monitor. It was a nightmare. I had to work split windows all the time. Yeah. I don't know, I quite like this one monitor. I guess it's just different workflows really. So what are we... Where's a good place to start? So... I guess we've got some like zeros in here somewhere, maybe. N dot L... Missive, that would have messed us up. Color. So we could have got a light color. Intensity. What's that like? Intensity is 1 at least. I don't know how... Yeah, the color's white. That was fine. I remember we did use this previously. So let's just have a bit of a play and let's just say... Let's remove the BDRF from the equation and let's just do that. See what happens. BRDF, that's what I meant to say. Right, so we get in the white light, so we're not getting the BDRF. BRDF, that's what I'm saying. BRDF in here. The bidirectional, I forget what it means. So by the looks of it, this is 0. So something is wrong. For now. Yeah, it's only a second monitor. I don't know. At the end of the day, you're going to have to then switch. You're still going to have to switch. And I don't know if it's a waste of time switching stuff. There's not much to switch between. Maybe. Maybe, I don't know. I have no idea. So the lambda is divide albedo by pi. So why don't we... So there's a multiply that's going on, maybe. So let's just put for the right. So the Cook torrents. Okay, let's remove the multiply by lambda and see if that gives us anything other than white. Okay, so we're getting something other than white. So this KD is apparently 0. Right, we've done metal. Oh, sorry, we didn't plug in the metalness. Wait, did we put metal? We put 0 metal. Yeah, I think we didn't plug in the metalness part of it, did we? That was here. Yeah. KD. Multiplied. Yeah, but this just removes it if it's one take material dot metal. roughness. Okay. So KD would still be 0 because it's just multiplying it by 1. So 1 take S. So is S just 1? If we put KS in there, are we going to get... It's the same, right? So S just must be 1. Well, no, it's not 1. It's got... So we put that F0 in there. F0 is lerp. 1 on the left. Albedo. Maleness is 0. So it should be 1 here. Right, so if you're getting... I want to add submol. So if you're getting this to mean the diffuse is 0, but you shouldn't have 0 diffuse, right? Zero diffuse for metal. But you should have diffuse for dielectric. So something's a bit off there. Let's bring up the... Oh, 0.42 albedo. Yeah, actually, isn't it? Good point. Oh yeah, I must have put 1 in. Yeah. I put 1 in there because there was other times where I put 1 and I just sort of muscle memoried it or whatever. I just thought, yeah. Right, thank you. Yeah, 0.04 in it. Right, that's showing up now. So I don't see any specular... Wait, where am I going? KF. Yeah, okay, I didn't edit that, that's good. Right, so the light is that way. The light is up there. So maybe we should make the light shoot towards us. So... When you say roughness, when roughness is set to exactly 0, I don't know any spectral visible. Try setting it to 0.1. Really? So it's perfectly flat though. Right, so you should basically make it 0.01. Right, I see. So maybe we should change. Wait, let's change the light direction as well. So we want it to come from in front of us. So put negative Z on that. Let's see anything there. Yeah, fully 1 doesn't have specular. Yeah, that's what I was thinking. I was thinking 0 roughness should have specular. Because if you play around with this thing here as well. Yeah, 0 roughness. Yeah, always on, right. Hmm. So what have I messed up here then? Roughness. Right, wait, so where's the specular term? Calculate cook torrents. We add the cook torrents on. So we pass in the F0. Roughness, surface normal, light direction, view direction. Cool. So maybe some of this is wrong. It's the Fresnel schlick. Have a look. Good old Fresnel schlick. Right, so it was d alpha and all that, right? Multiplied 4 times d dot n l dot n. Yep. Wait, did I miss something there? Where's the denominator? Right, numerator is all of this. Alpha, which is the roughness. Right, so for now, should we just return the Fresnel and see what happens? Wait, it's not the Fresnel. Because I modified it. Unit test. Ugh. Right, that's the Fresnel. So why don't we take away... Let's only display cook torrents. So that's the specular. Oh, why am I seeing... Oh, sorry, I didn't comment out the other return, did I? Sorry about that. Right, let's keep that one there for a minute. Okay, so I've seen a specular highlight. Oh, wait, we're seeing Fresnel. Yeah, the Fresnel thing show up. That's what I meant to say. Is that right? Something's a bit off. This is the Fresnel thing, so we should be... What are you passing again? The view direction and the half direction between the lights. Right. Okay, the light. Okay, so something to do with the light direction as well. That's fair play. So we're seeing something happen. Let's only look at the specular then. Take a look at Unity Technologies Packages Render Pipeline. They've got a BRDF Thing public? I didn't realize I had that public. Yeah, so it's just a silly mistake, right? Fair play, what do they have here? Oh. Didn't realize they did all this publicly. Interesting. Yeah. What? Well, okay. Right. Thank you. Right, what sort of license is this under anyway? It's under whatever their license is anyway, isn't it? I don't know. Anyway, I'll think about it. I'll leave it there, but I'll read it. Read the license off stream and see what it is. Okay. So let's see this cook torrents thing and see how that looks. Right, pitch black all the time. So that's kind of obvious. We're not seeing any contribution there. Yeah, ask ChatGPT's TLDR. It's probably a good idea. I shouldn't use ChatGPT at all. I played around with it though. It's interesting. But yeah. So our cook torrents thing is basically 0, which is kind of obvious because it is the So why don't we chuck the Fresnel on top of it? Something painfully dumb I'm probably doing. There we go. So it's in the Fresnel. Wait, we saw this anyway, right? We saw that anyway. Yeah, so if the view normal is perpendicular to the half direction, which is the, yeah. That's interesting, okay. But anyway, so this definitely, that's working. Then I guess let's comment out both of these guys and just see if this works. Right, we're seeing something here working. Interesting, so there's a bit of specular that's going on. So let's bring in one of them. Right, that's making stuff disappear now. And this other one. So the Smith geometry is the shadowing term. And it's just making everything go into a shadow. And so does this one as well in a way. Did I compile that right? Yeah, so they're both kind of doing it. So I guess let's inspect these guys. So we've got the Smith geometry. The roughness goes in surface normal. Surface normal's gonna right. Okay. Right, surface normal view direction, that direction. Right. Road bridge. half direction. Right, okay. So now let's look at the implementation of these guys. Make sure they are curved. Right, start here. So the Smith is right. So Schlick Beckman, alpha, surface normal, view direction, surface normal, light direction. So roughness, normal, light. Calls this same G1 function twice, then multiplies it as a scalar. So it's just that. Okay. So roughness, surface normal, then this X. POW, for some reason I'm doing POW 2. Am I paying for the GPT-4? No, I've not really, I only played around with GPT-3 or whatever when it came out initially, and I already played with it past then. I don't know how useful the newer tooling is. Roughness divided by 2. Wait. I don't have this. Interesting. Why did I do POW 2? That must have come from another one. Oh, copy paste error. Oh, this looks interesting. Right, I messed that up royally. Right, so n dot x to, I know it's k. Right, let's quickly take a look at this one. Sure got that right. Normal distribution function. Yeah, roughness. That's where I copied and pasted it from. This line here. So n dot h half vector. Pow to pi pow to, then the right hand side is right 2 plus 1 after the multiply. Yep. Right, that looks legit. So that should be the fix. Hey, through it out. How's it going? Welcome back. Oh, things are damn shadowing a lot in this. A lot of shadow that just comes out. Where should I see the specular? Should it have more intensity? Wait a minute, where's the light color? In all of this. So you're getting sort of play about with this. Alright, comes the Fresnel, doesn't it? Right, obviously. So the Fresnel will get the color. Right, okay. We saw that before. So as it becomes metal. Wait. The color, the metal. So if we switch it to metal, we should see it in the Fresnel. I guess we'll see a very tiny specular. Right, that's completely messed up. Whoops. Okay. Hmm. Yeah, it could be actually. They're not correct. That's a good point. Why don't we use the drawing code? So I guess we can pick a pixel and then we can draw it. Because we got the drawing API. We got the so we can definitely debug that. So how do you pick a pixel? That's the question. How do you pick a pixel? Where the mouse position is. If G. Alright. But you don't know where the mouse position is because you need to bring it. If debug draw 3D vector 3D vector world space surface view direction, and I guess you pass in a color. Thickness 1, color. Let's do a yellow or something. Then Z tested false. So let's just try and make. Well, it's going towards the view. You won't really see that. Let's try the light direction. So debug. So to do a debug, let's get the mouse position. And ball debug equal mouse position and right. So the mouse is over pixel U coordinate. Alright, so let's try that. We should be able to see something when we hover over the mouse. Right, so mouse is going over, but we're getting the surface. Right, the surface could be wrong. Because I'm pointing here. Oh, the hit position is in view space. Yeah. So hit pause world space. I think that's it. So we try that. Hit pause. That might be the thing that's wrong. Still a bit messed. World from view. Huh? Ray origin 0, ray direction. Ray origin plus, yep. Direction times t, yep, that's right. So when we perform hit position, yep, seems legit. Anything else that's causing... Right, so I guess... Let's move the camera. What? Ah, multiply vector. Whoops. Point. I was not doing any translation. Right, that's better. The starting position is correct. The direction of this, however, is a bit wrong. So, light direction. So when I took away the light, yeah, but it's in the n.l in the right way, right? So, yeah, the direction of the light is going down. That's correct, because the light is up there. That's fine. So my thing is about it though, like... You get the right half vector, the two inputs, the light direction in here. Yeah, the light vector, I think it's pointing, it's got to point towards the light. But when it does like the n.l and all of that, be negated. Yeah, towards the light, innit? Wait. Huh? Why is light dirt towards the light? Wait, what's going on? Oh, shoot. Right, y needs to be positive to be up in the sky. Okay. I see where the problem is now, at least. Hmm. Why is it pointing down? So it's up in the up, back. Oh, I didn't normalize it. Whoops. Right, that's part of the issue. Right, we're getting very darker scene. Right, why is the light dirt still pointing downward? So if I... Hmm. Light direction. Let's draw a few more. Let's draw the green as half. Let's draw that one as well. They're pointing basically the same way. Okay, good. So something's really weird with this light direction. What is going on? Should we print it out? GPU hprintf f f f lightdir.x lightdir.y. Right, so we see that on GPU, it shouldn't have changed, right? So we're hovering over here, not showing up in the, because all the profiler stuff's in the way. But yeah, we're getting positive Y and negative there. So Y, this is in world space. Am I doing something funky with, I could have swore these were fine. Like, the surface position world space. That's the one where I'm pointing the, where I point the mouse, that's the surface position world space. You're seeing it's coming from there. So we know it's coming from the right place. So there's a vector 3D. Am I drawing this wrong? Like if I just draw, let's draw another one. We'll always draw it. Debug. Let's just put it at 0, 0 in the world. And let's point it towards, let's point it at like 0, 1, 0. Is my Y wrong or something dumb like that? Yeah, I'm not seeing that show up. Do an ugly blue. What is the value you have? Yeah, I guess we can look at it in a sec. Oh, 0 and 1 must be really small. No? Saw it show up just then. Ah, there it is. That's what 0 is in the world. Huh. Well, they're normalized, right? Normalized. Let me turn off the profiler. What was all this tile crap showing up? Ah, there it is. Tile index. somewhere there's another print. There we go. Alright, let's get out of there. Alright, back to sensible things. So the light direction, so what I want to get is why are these printing, oh sorry, why are these debug drawers long? They're huge. So is my debug drawing wrong then? It did work in the past, I tested it. So when you say it's in, maybe, did we only test view space? Ah, shoot. That. Mol V. Damn it. Shoot. So I need to make sure that's doing that anywhere else. So we probably did the CPU side, that's got the same issue because we've got two implementations, one GPU, one CPU, which is nice. But yeah, it's got the same error. So I think that's the issue. Right, okay, so now they're really small. So let's scale the size of that thing. Right, so what we really want is to multiply a vector, you know, maybe bring the thickness down to 0.1 instead. What? The y point's down, no, y point's up. So I don't know what's wrong. They need to be bigger still. Let's scale these by something. By like 10. So you see this blue here, this blue one. Yeah, y point's up, you see in the blue one. Yeah, bit thick though. Right, so you can see that now. The light direction is saying that it's... Right, I think that's correct. The half vector looks a bit weird though. So if I look at my light, we actually want it from far. Pointing this way, pointing down. And then I negate it here, I guess. Nah, let's just do it that way, then otherwise there's a negate in the shader. That points towards the light. Okay, so now our light is that way. The half vector though looks a bit weird. It points... So let's get the V vector in there as well. Camera position. We can plot these camera positions and that. So we can do a point, sphere, surface position. Right, so let's do a color of like blue or something. That'd be the surface hit point. We should see it show up. Maybe we should make it a bit bigger. So it'll be bigger than the vector that we're drawing. Yeah, as you see, it's on the point there. So that's fine. What about let's draw a red one for the camera position. But the camera position should be where? The view, yeah, that's not going to be visible. Let's do another vector one, which describes the view direction. And that one will be red. All right. Well, that's not good. Oh wait, no, it's pointing towards me. That's fine. You can see the point. So the half vector doesn't look good because I'm looking at it from head on. Right. So if we just hard code the camera position, there we hard code this to be like it's coming from the right hand side. Then you'll see the half vector and how it works, and that should be okay. So yeah. So if the camera is coming from the right hand side, so it goes over there, the half vector is definitely in between the light, which is coming up there, up here. So the half vector is coming from there. So that looks fine. All right, so these are looking good now. I guess we didn't really change much. So I'm confused what the problem still is. So so did the Cook torrents thing, that's where the specular is. Yeah, the half vector is between the view and the light vector, so that was the green one. It is between the half and the view, right? This is me just debugging it here. I'm just debugging it, so I fixed the camera. I fixed the camera one for a second. Now it's just changing it back. It now points towards the camera, and there's a half vector. Yeah, so to get the specular, it needs to be... I'm expecting to see it somewhere. Nah. Half was green. Okay. So I wonder why. So those vectors seem legit. What else could it be? You got KS, KD. So we know the Fresnel is correct. Yeah, we know this was correct. The Cook torrents is the specular, so that's the issue. We know the Fresnel works. The Smith. We did fix a problem in the Smith. And the Schlick Beckman. That was the surface normal. Yeah, we fixed a problem in that one. Let's try that roughness with a 0.1 as someone suggested, but I don't think that's the issue. But you should be seeing a... What direction is it going to be? Should be seeing some specular term. Don't know what's going on. So, what do we change again? All right. So the Smith. So what gives you that actual specular highlight? So this would be, the Fresnel would give you, let's look at this. So dielectric. The distribution, the normal distribution function, that gives you that glow. So, right. So we're getting this geometry part. It's just a normal distribution function. That's probably wrong. So where is... That is the GGX Trowbridge. So visibility term, is that it? Yeah, visibility term. GV. Right. N dot H. See, this one is a different one. Oh, sorry, distribution. This is it. Right, N dot H times R2 is roughness squared. Yeah, so that's the denominator. N dot H. This one is, oh, interesting. This is different. Definitely different. Yeah, this is, wait a minute. Oh, maybe it's a similar. So there's the pi dd. Yeah, there's a pow. There's the pow. There's the dd. Yeah, this is really annoyingly written because the problem is the code where I took it from uses PAL2 a lot. But yeah, I guess let's refactor it. This looks pretty similar. This looks like same function. There's a plus. There is a take one though. And then there's a plus one. It's a bit different. So let's go back to here. Normal distribution function. Right, so this is problem asking to happen, isn't it? N dot H pi pow n dot H 2 multiplied, and in brackets, goes up to -1, and roughness pow 2. We should probably just call this R2 then and just shorten it a bit. Where's my normal distribution function? I don't know why I'm doing PAL2 like that, not gonna lie. Should definitely start doing this more. So that's R2. Let's shorten that a bit. So this wants to do an R2, take 1, then the multiplier happens between the POW. Yeah. And then a +1 happens after that. And then a power happens on that. It looks the same to me. Am I passing in the vectors in the right order? It says the Cook torrents. Yep. Calculate BRDF. Material, surface normal, light direction, view normal, F0. It's in the right order. Yeah, so there's a row bridge, surface normal 1/2. We should be seeing this. There's a whole bunch of these same, or maybe not. Let's look at that Cook torrents again. Yeah, 4 times. Did I miss that N.L? No, I didn't. That won't be the issue. So I guess we could plug in the GGX Tro bridge and just see what that returns. Maybe the light is too far. It's just a, well, yeah, it's infinitely far away. It's a directional light, but the intensity is not a problem. It's all about the direction. There's no intensity or color, light color coming into any of this stuff. So yeah, it's a bit of a weird one. So let's just try and return that and see how that does. So we're not seeing anything. Let's we could print this out. But I need the debug thing. Right, so it's only look at Cook torrents as the BRDF. Right, so I'm moving around and I don't see anything happening. So it's obviously wrong in some way. Still just with this. Let's try and just return the Smith geometry. And see if that returns anything. Hopefully this does. Right, so this returns something. This. Cool. So it definitely does contribute something. The Fresnel does, but this row bridge one doesn't. Off direction. We can maybe start hard coding stuff. So what would be, well, no, hard coding would be bad. So the Tro bridge, it does an n dot or whatever. So where this needs to be 1 is when this is gonna get something sensible, right? So if we encode it to be directly up, then what do we... I still get nothing. So surface normal. Problem is R2 is basically 0. It's basically 0, yeah. 0 take 1, so you say minus 1. Oh. Seem good, does it? What's being passed into this thing? So the distribution term. Yeah, maybe we should use this version. I think this one just seems off. Right, let's comment this one out and use another one. Right, R2 D n.h R2 take n.h multiplied n.h. Definitely different. +1. So this might not be a GGX Trowbridge anymore. Similar though. R2 divided by D squared multiplied by pi. Sorry, R2. There we go. That's better. See, the normal distribution function is... Finally. That's a bit big though. And also, which one are they using here for this distribution term? Oh, kind of loud. Shader toy. Do you have any comments about their shade and distribution term? I don't know what it is. Doesn't even say. Yeah. I don't even know. That's annoying. It'll be good to know which one it is because I've got it written as the to do. It's probably GGX something. Right, so let's put that in correctly now. And we should see the full piece of the pie. What is going on? Right, I'm just seeing the torrents. Right, there's a little bit of a specular hint there. It's Diddy though. Why is it so faint now? It was so much bigger, and we're getting color banding as well. It was so much bigger when I just returned it. So it must be the shadowing thing. Right, I've had a bit of roughness on it. Now it's completely gone. What? Right, so I only see the specular. Right, when it was 0, it doesn't show anything. So I do need a bit of roughness on there. That's wrong. Damn it. So you do need a bit of roughness to get the specular. Doesn't seem right. There's obviously something in here. There's probably a division by 0 happening in the... Oh, there used to be this in the code. So you basically need to max this. Kind of, probably. Nope. You still need some kind of... Because if n.l, that could be times 0, take that, that'll be like negative or positive 1 or whatever. Sorry, it'd be 0 to 1. So it can go into the negatives. If that is 0. And multiply that by plus 1, so it could end up being... Maybe it could end up being 0. Maybe. Maxing is probably not correct. I don't know anymore. Yeah, something's funny with it when roughness is perfectly 0. That's not good. Right, okay. Bridge, let's put that back. Right, so it's showing up. Getting a little dot, a little specular highlight at least. They're looking plasticky now. It's flickering when you move a bit. What makes it bigger? What makes the specular highlight bigger? Very small. Make control check in real time. Yeah, that's something I want to do. Want to play around with. We can do that now, but I haven't got enough time to add those controls in. That's something I want to do. But yeah, I think, yeah, I don't know what it is. Like, is it if I change this value? Does it make it bigger? Then it probably makes it more faint, right? Bigger and more faint, probably. Oh, there's that F0 value as well. No, the intensity, there's no color or intensity going into the specular highlight for some reason. Oh no, there is. No, there is. It's going, it's not going into when you calculate the BRDF. It's done after you calculate the BRDF. You multiply that. So the BRDF, it basically returns diffuse plus specular. Right. So it is intensity. BRDF comes out here. Then we multiply that by light color, which has the intensity in it. So it is probably is not that intense, right? So we make that like 10. We should probably make it like more maybe, but there we go. I don't know. No. I guess if you make it a bit rougher with some intensity maybe. Or you know what it is? They're spheres. Maybe. So there's less normals pointing directly in the direction of the light. Probably. That's probably the answer. So this, I don't know though. That's just a guess. Probably wrong though. I don't know. It's looking better than it was. We've still got to get the metalness to work. Right, so I think I'll do I actually didn't take... If roughness is 0, then d term should return 1 in case where you've divided by 0. Yeah, d term, normal distribution function. Yeah, it should return 1, but it's not. That's something to investigate, isn't it? We should write all these things down for next time. Next time. So this guy should return 1 when roughness, well, not really 1 when it's perfectly lined up in it. Yeah, this should allow for roughness 0. You know, we probably want to sort of find other implementations online, right? Find other implementations or see the actual formula for it, and and sort of work out what is correct, because we tried this one and it just didn't work at all. It was weird. So there must have been a typo in the YouTube video or something. I don't know. It was definitely wrong. Because UI controls to control, to control materials and lighting. So we can play about that with that live. And we probably also want the ability to manually inspect the individual terms, like this one is doing. So maybe having the ability to see diffuse, specular, distribution for now, and geometry, so we can see that manually without having to recompile every time. To control viewing each part of the PBR. Rendering individually. Individually. Right. Cool. Right, so let's do a round uptake. Okay, so we end up going and implementing all of that PBR code. So this is basically what we've ended up with for now. There are some bugs, like we haven't tried the metalness out. Well, the metalness just didn't work for some reason, and the normal distribution function ended up causing us some problems, so we tried out a different one for now. And this sort of specular highlight seems a bit small. So, or maybe it's small, maybe it's fine because it's a sphere. I don't know. So there's things to still investigate, but at least things are looking sort of plasticky, which is nice. And these lines here are the vectors. So the yellow is the points towards the light direction. The green points towards the camera. Sorry, the red points towards the camera, and the green is the halfway vector between the two. So I was using that to debug some of the inputs and stuff like this. So yeah, we basically went and implemented all of these sort of like normal distribution functions, the geometry shadowing function, the Fresnel function, the specular term, those Cook torrents, and then calculating the BRDF here and then plugging it all in. So next time we're gonna fix up this normal distribution function because it appears to be wrong. It's not allowing for roughness to be 0 for some reason. And we also had to try a different implementation, and I don't know which one it is. I'm not sure if it is a GGX Trowbridge anymore. But we're gonna make it so we can actually control the materials and lighting live without having to edit shader code and debug, compile and run, and also make it so we can control viewing individual parts of the shader code. So basically make something like this so it will help us debug what's going on inside the shading code. And so have a bit of a play with the things in our code base, and it'll be nice. Yeah. Maybe do that one again. How do you make debug vectors? They draw on a shader without vertex there. Yeah, so basically we just have a buffer and we append to it so it's a very quick and easy implementation. I think I've got the VOD somewhere. So I'll link you to the VOD if you want to see more of a detailed version, and I'll give you a quick rundown. Debug drawing part 02. Yeah, there's only 2 videos to watch. And it did 2D and 3D. So basically they work the same way. They work exactly the same way. Basically we have a buffer which stores an array of U32. And whenever we do a draw 3D whatever or draw 2D whatever, it's basically allocating 9, words. A word is a U32. We get an insert index. We get the buffer that we're writing it to. They're global, accessible from any shader. You have to be wary of putting synchronization code in. So I just automatically put the sync code on every shader in debug mode, which obviously puts barriers between everything, but that's okay. We have wait, I maybe don't need the sync code, do I? Because I just need the atomic. No wait, you need the cache flushing. Yeah, maybe you need it. Yeah, I think you need it. But anyway, then we just fill in the words bit by bit, right? So we convert floats into integers, reinterpret cast. So we just pack everything we need. We put the shape type at the front. And this alloc words, it's just adding to an atomic integer, which I think it sits in some other global buffer somewhere else. So it's just it's bump allocating words. And then all we do is we just do a full screen ray trace. And at the moment, it's not optimized at all. So all we do is do a full screen ray tracing in a compute shader. We go over every single word in the draw 3D or draw 2D. It's a separate shader, right? For draw 2D and 3D. And then we essentially do the Z testing. Check if any Z testing. That's a bit in the first word. Then the rest of the bits represent the shape type. And we just switch on it per pixel and just do a ray verse box in this case, or ray verse orientate bounding box, ray verse sphere, ray verse vector. So it's just ray tracing all of those different shapes. So you can add whatever shapes you want, basically. Yeah, we've got vectors, spheres, and boxes, basically. Right, I think I want to do a roundup video because it's getting really late. Okay, so that does it for... Oh, it is. Set up right. Ooh. Right, that does it for devlog 13. So if you want to catch the... Oh, yeah, let's do it one more time. Right, that does it for devlog 13. Thank you so much for watching. So it's great we got the PBR showing and up and running in some way. But yeah, so next time we're going to get all those parameters all configurable live so we can debug more of what's going on under the hood and just play around with PBR in general. So if you want to watch the full stream online, it's day 120 and you can catch the VOD on the VOD channel. There's a Twitch link there. If you follow that, you'll get the full schedule in your time zone. You can come and tune in live. There's also a Discord link at the bottom there. You're going to come and chat outside of the streams and VODs. There's also a link to support me up there, and if you support, you get access to the source code. Right, I'll see you in the next one. I think that'll do. Man, I'm so tired. That should be done. Well, at least we got something working. That was good. Let's find someone to raid. I'll next be on Thursday at 7:30 p.m. GMT +1. And yeah, we'll get some UI up there and be nice and configurable, and hopefully get the PBR finished, I reckon. Then we can move on to other things. 3 last miles. That's going to be a very short devlog. There was not many takes in that one. Too busy just pulling all the PBR code in. Right, have a good Wednesday everyone. I'll see you all Thursday. Catch you later. Bye.